Hello everybody. In this video, we will discuss about the types of locks and lock compatibility in lock-based protocols. In a multi-user database environment, lock-based protocols are used to ensure consistency of concurrent transaction execution. A lock is a mechanism to control the concurrent access to a data item, and the lock can be of two modes. One is shared mode lock and another one is exclusive mode lock. A transaction that is granted with the exclusive lock on a particular data can perform both read and write on that data. Same way, the transaction that is granted with the shared lock on a particular data can perform only read operation on that data. The exclusive lock is requested using lock-x instruction, and the shared lock is requested using lock-s instruction. And the lock requests are always made to the concurrency control manager, and the concurrency control manager will grant the lock upon checking the compatibility of the locks. Now, we'll understand about the compatibility of the locks. And this is a matrix that is given for lock compatibility. So, I explain you what it is. Okay. So, let me number this and I'll show you examples for each case. Okay. So, the first thing is that let us consider a transaction T1 acquired already, granted with the particular S lock and X lock already, and let us consider this as requesting T2 request for that particular one. Okay, so we'll first box this one is, let us consider the data called as A. The transaction T1 is already granted with the shared lock on A. So with the shared lock, what it will do the read operation. So R bar, which I indicated as read operation, is in progress. Okay. Now, in this time, if another transaction called as T2 is coming, and it is also requesting for the shared lock. Okay, so if shared lock is given, what is a permitted operation that it can do? Read. Then two transactions, two different transactions, read the data at the same time. No kind of consistency damage is going to occur. So, in this case, when T1 is already granted the shared lock on A, if T2 also coming and requesting for a shared lock on A, it will be granted. That is what the compatibility is mentioned as true. Same way, like T2, if T3, T4, T5, many other transactions wants to request the shared lock on A, it will be granted. Okay, because all the transactions are just going to read, it is not going to update. Okay, so when two transactions are executing concurrently, one is reading and another one is writing, at that case definitely the data inconsistency issues will occur. And here no kind of threat like that is there. So here T2 is granted. Okay, the T2 request for a shadow lock again. T2 is granted with what now? S lock. Understood? That is what this is. Okay, and the second square which I want to explain you. Okay, so let us consider again the same data called as A. The transaction T1 is already granted with the shadow. Okay, so let us assume that for in this box, T1 already granted with the shadow on A. Okay, with the shadow what operation it can do is it can perform only read. So, read is in progress. Okay, so in this case, if T2 transaction comes, and if it requests for a exclusive lock, with exclusive lock, what are the operations that it can do? Is read and write. Okay, so when T1 is already granted with the shared lock, it is performing read operation. Another transaction called as T2 should not be allowed to write. Okay, so when a transaction is reading and another transaction is a consequence that concurrently keep on updating the data, then that reads will be the reading of wrong values. So this will lead to inconsistency of the database. So in order to avoid that, what is the action that is taken by the concurrency control manager is T2 is allowed to wait. It is not granted. Okay, so it is not granted with the exclusive lock. It is supposed to wait. That is, it is not allowed to interfere while the transaction T1 is performing the read operation using the shared lock on A. Okay, so that is why it is mentioned as when a data is already locked in shared mode, exclusive lock request will not be granted. If the transaction that is requesting for the conflicting mode of lock will be allowed to wait. Okay, and that is what this square means. And let us consider the similar case, the similar way you understand the other compatibilities also. When a particular transaction called as A, sorry, a data called as A is granted to T1 in exclusive mode. With the exclusive mode of lock, the transaction will perform both read and write. It is assumed that the T1 is already granted with the exclusive lock and it is doing read and write, it is in progress. So in this case, when T2 transaction comes and if it requests for shared lock, okay, with the shared lock, what is it perform? Read operation. When one transaction is already writing, another transaction should not be allowed to read. Okay, so because the values may be inconsistent depending on the order of read and write. Okay, so until it completes its operation and releases the exclusive lock, T2 is allowed to wait. Okay, so T2 is allowed to wait. It's not compatible. If we allow that, some kind of inconsistencies in the database will occur. So the concurrency control manager will use this compatibility check to decide whether the transaction could be granted with the lock or not. Okay, so in this case, T2 is allowed to wait. It is not granted with the shadow lock. Okay, so that is why it is mentioned that already a particular data is locked in exclusive lock mode, then shadow lock on the data would not be granted. Okay, and the last thing that you can understand is when a data called as A is already locked by T1 in exclusive mode, with which it is performing both read and write operation. Another transaction T2, if it requests for an exclusive lock, as you know, it won't be granted. Why? Because already a transaction is performing a writing operation. So another transaction is not allowed to do another update or read the value, or it's not allowed to update the values of A. Okay, so it should go like one after the other approach. So the concurrency control manager will decide not to grant the lock to T2 and T2 will be allowed to wait. Okay, so this is what about the lock compatibility, and all the lock requests that is done by the transaction is made to the concurrency control manager. Concurrency control manager, upon checking the compatibility of the already held locks and the lock that is requested by the transaction, it will decide based on the compatibility whether to grant the lock or not to grant. Okay, if the lock is not granted, the requesting transaction is allowed to wait until the requested lock is, that is requested data is available. Okay, so this is what about the types of locks and lock compatibility. Hope you understand the concept. Thanks for